All right, welcome back, students. This is example 2 from lesson 19.2, and this time we're going to be looking at horizontal translations. So what you need to do is you need to write the definition of what a horizontal translation is, and then I need you to write everything that's in this little box down in your lecture notes so that you can refer to it as you are working problem B, the reflections, and the your turns. Go ahead and put me on hold, write it down, and come back when you're ready. All right, so this time you notice your function looks a little bit different. You'll notice that the function looks like f of x equals. This time it's in parentheses, and you have an x minus h squared. Now, this is different from the parent graph because the parent graph looks like f of x equals x squared. So you notice the difference is the fact that there's an h inside the parentheses and the fact that the h in the parentheses is negative. Okay. The best way I could describe this is if k was not in the parentheses and k was a vertical translation, then the opposite of not to be in the parentheses is to be in the parentheses, and the opposite of vertical is horizontal. So if you see something in parentheses, then it's a horizontal translation. Okay, the same holds true. If h is bigger than 0, in other words, if h is 1, 2, 3, 4, all the way up to positive infinity, notice this time we're going to be going right that many units. If a is a negative integer, okay, anything negative 1, negative 2, negative a million, negative infinity, then it's going to fit in this mode. And if that's the case, then you take the absolute value of h and you'll go that many units to the left. So say, for instance, if h was equal to negative 10, then the absolute value of negative 10 is 10, so you'll go 10 units to the left. All right, so for these examples, and we're only going to do part B for this one, you'll notice that it says, okay, so I had the wrong picture, so I had to put in the right picture. So this is example 2B. In example 2B, we're going to do a comparison to the parent graph. This time we are doing g of x equals, notice it's in parentheses, so you know it's going to be a translation horizontal. If it wasn't in the parentheses, it'd be a vertical translation. So again, how do you do these? Pretty simple. You do the g of whatever you're going to plug in. This time it's going to be inside the parentheses, plus 1, and then we're going to square it. So take, for instance, this negative 3. I'm going to plug in negative 3 here, but I'm also going to plug in negative 3 here. Right? Now, with that said, we got to keep in mind PEMDAS. So here we go. I want to look inside the deepest set of parentheses because right now I have, again, what's called nested parentheses. My deepest parentheses is this negative 3. So if I look in this negative 3, there's nothing I need to add, subtract, multiply, or divide from it because there's nothing right here and there's nothing right here. That means these parentheses are useless, so I'm going to go ahead and drop them. So now I go back to my parentheses. Is there anything to do in the parentheses? And the answer is yes. Negative 3 plus 1 is equal to what? Okay, so that would be negative 2. And I'm going to square it. All right, what is negative 2 squared? That means I'm going to get g of negative 3 is equal to 4. That means this one's going to be a 4. Okay, so you could go ahead and pause me, get a piece of paper, something to write with, a calculator, finish the rest of them, fill them out, and then come back to make sure you did them correctly. Go ahead and hit pause and resume when you're ready. Okay, so the next set of numbers are going to be 1, 0, 1, 4, 9, and 16. So those are all my ordered pairs. Now, again, keep in mind you're going to need to write down the ordered pairs for the regular parent graph. Then you're going to need to write down the ordered pairs for the g of x. Okay, now take a look at the graph. Got to make sure we got our graph settings right. Looks like it's the same one as last time. Okay, looks like it's going to start at -7, run all the way through all the x's until it hits +7 with a step of 1 and no title. And for my y's, again, looks like I'm skipping by 1, so it's going to be -5 all the way through all the y's until it hits 11 with steps of 1. All right, once you get everything written down, go to decimals and follow along. Okay, so here we go. Hit graph settings, take off minor grid lines, and let's go ahead and reset -7 to +7, steps of 1, -5 to 11, steps of 1, close. First things first, I want to do the table. So I'm going to go get me a table of values, and I'm going to do the parent graph. Parent graph is going to start at -3, go to 9, -2, go to 4, -1, go to 1, 0, go to 0, 1, go to 1, 2, go to 4, 3 goes to 9. Now we're going to go ahead and do the parent graph, which is x squared. And I'm going to, again, because I want to make sure they're color coded, I'm going to come over here and hold and change it to green. Okay, now I'm ready for my second table. Hit table. This time we're going to do -3 goes to 4, -2 goes to 1, -1 goes to 0. That means 0 goes to 1, 1 goes to 4, 2 goes to 9, and 3 goes to 16. Okay, I don't like the dots being the same color, so I'm going to come over here and change my dots to, I don't know, red. Just to make them be a little bit easier to see. Now, don't know if you can see this clearly. So the best thing to do right now is to put my line in, and remember the parentheses. So I'm going to have to do open parentheses, x plus 1, close parentheses, and square it. Okay, so here we go. If I look really close at this, okay, and I'm not allowed to move the graph, because if I move the graph, I'll come off of the graph settings. But if I were to copy this thing, and again, I like large because it gives me more dots, download it, give it a few seconds, let me open it up, and let me get my little, okay, there we go. If I were to look at this, remember the green line is the parent graph, the black line, I never change it to red, but the black line is the changed graph. It looks like it moved which direction? Okay, I'm going to do this so you can see it just a little bit easier. This was the original axis of symmetry. Okay, that's where my original axis of symmetry is. Now I'm going to use red to show you where it moved to, and hopefully this will make a little bit more sense. Here is my new axis of symmetry. So it looks like it moved this direction. And how many units did it move? Well, if you remember, h has to be the absolute value of h. So if I take this -1, plug it in here, I get 1 unit to the left. So it moved 1 unit to the left. Now, here comes the hard part for some people to understand. If you go back to the original equation and you look at what we were working, it looks like it says 1 unit to the right. But in order to understand how the formula works, notice the formula has a negative built into it. That is not by mistake. That has to be there in order for it to work right. So it looks like if I'm in this parentheses with a negative h, then the only other thing I could have plugged in to get a positive 1 would have been a -1. That's why it moved to the left. Even though, again, I hope this makes a little bit of sense, even though g of x, and I gotta be careful the way I do this, even though g of x was equal to x plus 1 squared, it looks like it moved -1 to the left, and that's exactly what it did. Now, why is this working? Because in order, and I hope you kind of put this together in your head, the only thing that I could plug into here to get a positive 1 in my generic form had to have been a -1. That confirms with me it had to be a horizontal shift to the left. So now we're going to come over here and answer our final questions. And our final questions is it a maximum or a minimum? Well, since they're both opening up upwards, that means whatever this is my lowest value on the on the y-axis. So it looks like my minimum value on the y-axis is going to be 0. So I plug it in 0 here. Now, where did my axis of symmetry move to? Remember, axis of symmetry is an x value that the axis of symmetry cuts through, and this one looks like it's cutting through -1. So I come over here and I say x is equal to -1. Hope that helps. Don't forget to copy and paste the graph onto the worksheet, onto the guided notes. And if you have any questions, shoot me an email.